3 interstellar objects have ever been confirmed entering our solar system. Only one of them has now been photographed by a spacecraft. This is 3I Atlas. Not from Earth, not from a backyard telescope, but from ESA's JUICE spacecraft currently on its way to Jupiter. At a distance of just 0.44 AU, JUICE turned its science camera toward an object that didn't originate here. That matters, because spacecraft data is different. Sharper calibration, different viewing geometry, independent confirmation of activity. So, what does this first image actually show? Is it just another dusty comet? Or does the geometry reveal something more about how interstellar objects behave near the Sun? Let's break down what JUICE really captured and what it tells us about 3I Atlas. On the 27th of February, 2026, ESA released something we've never had before. The first spacecraft image of 3I Atlas. Not from Earth, not from a ground telescope, but from Jupiter Icy Moon's explorer, JUICE, a spacecraft currently traveling through the inner solar system on its way to Jupiter. At the time of observation, JUICE was approximately 0.44 astronomical units from 3I Atlas. That's closer than many Earth-based observations. And this object did not originate in our solar system. It came from interstellar space. So the question isn't just what we're looking at. The real question is, what does spacecraft geometry reveal that Earth-based imaging cannot? Let's break it down carefully. First, the context. JUICE was not designed to study interstellar visitors. Its primary mission is the Jovian system, particularly Ganymede, Europa, and Callisto. But during its cruise phase, mission planners used the onboard science camera to observe 3I Atlas during November 2025, with the process data released on February 27, 2026. That timing matters, because what we're seeing is post-processing from calibrated spacecraft instrumentation, not a social media enhancement, not amateur stacking. Now look at the structure in the image. You see a bright central condensation, a diffuse surrounding envelope, an extended dust feature aligned roughly anti-solar. The arrows in ESA's release indicate direction toward the Sun, the object's velocity vector. That geometry is important. From Earth, viewing angles compress tail structures. From JUICE's vantage point, the scattering angle is different. That changes how dust reflects sunlight. This allows scientists to analyze dust particle size distribution, ejection dynamics, forward versus backward scattering, activity symmetry relative to solar heating, and here's the key point. Spacecraft imaging reduces atmospheric interference and gives independent phase angle data. That means we can test whether the activity is consistent with solar-driven sublimation or something anomalous. Right now, nothing in this image suggests non-natural mechanics. What it shows is structured outgassing consistent with a volatile-rich body responding to solar input. But the dataset is new, and this is the first time an interstellar object has been observed from a spacecraft during cruise. That alone makes it historic. So yesterday we looked at 3I Atlas under difficult observing conditions, stacked exposures, bright moonlight, and the IAU stepping in to address speculation. Today we're looking at something different, a spacecraft view, a new geometry, independent phase angle data, no atmosphere, no backyard optics, just calibrated instrumentation observing an interstellar object from inside the solar system. And so far, the physics holds. Solar illumination, dust response, expected scattering behavior. Nothing exotic, nothing impossible. But here's the deeper question. If even spacecraft data confirms natural activity, what kind of evidence would actually change your mind? What would it take for an interstellar object to truly challenge our current understanding? Let me know your standard of proof in the comments. And if you value careful, evidence-first analysis without hype, subscribe to Space Unfiltered. Because when the data is this rare, clarity matters more than ever.